Okay, so yesterday, before we finish our lecture, I just stopped here and even I run the analysis to show you the results. So what I did actually, I unlocked this model again so that I can run for you analysis again and show you the results, how you can extract your shear force and bending moment diagram. So let us again run the analysis. Once you run the analysis, it will give us the deformed shape. When deformed shape is there, it means that your analysis is finished. So you can see here on the right side of the screen, the beam is deformed now. So it means that analysis has been done. Now I will come on the middle screen and I will go and open the results. Now, how we can see the results? You have multiple options. You can go to display, click on display. You will find a lot of options there, which include the undeformed shape, because now this is deformed shape, so you can make it back again, undeformed. Second is the load assign. If you want to see what loads you have assigned to the members, you can come and you can click on that one. Let's say you forget what load you did, you just come and click on this one and you will see it will start asking which loads you want to see. Now this dead you cannot see because this dead is related to self weight. So it will not show you how it is acting, but you can see the live load, you can see the superimposed load. So if you click on superimposed load, you say apply, you can see on the background now the load is also appearing. Now, same thing, you can confirm your live load also if you have applied any live load. Yesterday we did not apply any live load, so I will tell you now because we need to run combinations there. Okay. Now we this is our load. Now if you go to the display again, you will find uh, fourth option, which is representing force slash stress diagram. You can come and click on the first option, which is support reactions. If you want to see the support reaction, you just click on this one for which load you want to see, or you want to see for the combination. We created combination also yesterday. Now for the time being, I will look at for the load because we didn't apply any live load. So there will be no reaction due to the live load. So no need to see the combination. We will once we unlock this one, we will apply again the live loads and then we will check that. But now I will say apply. Now, in which direction you want to see the reactions? Most of the time, as I said, that you are modeling it in XZ plane. So vertical reaction will come in Z direction and your horizontal reaction will come in X direction. If it is three-dimensional, so you can see also in the other direction. Now we need to see FZ or FX. You have option, you can even check all these one. You click on these all options. If there is any reaction available related to X, Y, Z, it will show you all of them. Click apply. And you can see here because we don't have any horizontal load. So these are the reactions which you are observing. If you want to see the detail, you just bring cursor there. It will show you all the reactions also. Fx is 0, Fy is 0. Then only Fz is there. There is no moment. Okay. Now, this is one thing. You can right click on the joint also. When you click on right joint, you will see that it is showing force moment. And now here you will not see in terms of F, Y, F, Z, F, X. Main thing, when you click on the joint, it will always show in the nodal direction, means the local axis of the member. Now, this I will explain you what is local axis. But at the end, your 3 is representing Z, 2 is representing your Y, and 1 is representing X. So 1 is always the longitudinal axis of the member. Now, what is the longitudinal axis? This is the direction of the member. So longitudinal direction X, 1. Other direction automatically will become 2 and 3 is always Z direction. Okay. So if I flip this one, if we model column, so what is going to happen? Column will be a vertical member. So longitudinal direction will be 1 again. and 2 will be the opposite, and 3 is always z. Okay, so this is how we define our local axis. Now, next, I want to see the stress, or I want to see the moment diagram or shear force diagram. You need to come to the force diagram and click on frame. When you click on frame, it will ask what you want to see. You want to see axial force, moment, and shear. Now, when that I model it in ZX direction. So by default, software will consider moment 3, moment about uh, x-axis or about z-axis. It will always give you results in 3 direction. Okay. If it is three-dimensional system, you need to check in other direction, which is so because in three-dimensional system you have moment about this axis, maybe moment about other axis, or there is a torsion. So one of the moment is causing torsion, other two are causing bending. So you can see the torsion also, you can see the moment if you have two-dimensional moment, because in our buildings one beam is coming from this direction, another beam is here, and then you have a column. So what this beam is trying to do, it is trying to bend in this direction. This beam is bending, so you have two moment transfer to the column, so you have to see both values. Okay, now I will go with M3 and I will say now we need to see for which load combination again. Now in this case, if you look at our first case was what? Total dead load, factored dead load, which include 1.2 self weight plus 1.2 times our superimposed load. If you go back here, this was our factored load, which is 21.68. So I need to observe this moment diagram. So what I will do, I will go here. I will choose 1.2 dead load, which we created yesterday combination. If you click on this one and if you say apply to this one, you will see numbers are now appearing on this one. Now I will just zoom this one for you guys to observe. Now, what is the number here written? 53.909. Now, if you look at here, what was representing here? 53.94, because what density I took here? 23.6 in my manual calculator, and a software was taking it as 23.56 up to some decimal actual density. So results are not big different, 909 or 94. They are not uh, much difference. So if you come here, you just zoom it up, you will see here 106, then all those numbers are there. Now, these are our factored moment for the dead load. Now, if you can get these maximum moments, what is the next task after your analysis? Just take these moments and go to the manual calculation, do the design. Maximum moment is there. So calculate steel ratio and then find spacing, all those, because it is the only issue which you are facing in the continuous. Now, this is only with the dead load. Now, ACI code says that we need to create multiple load cases, which includes loading of live load in first odd panels, then even panels, then two continuous panel, which I showed you last time. These are the combination we have to create. So what I need to do is I need to go and create these combination. Now, those who use STAD Pro before, what you have to do in the STAD Pro, if you have run the analysis, STAD Pro, you use the other software. Now, if you, I already completed and I run the analysis, results are there. If you want to do any changes in the stat, you cannot do it very easily, or there are ways, but that comes only from the coding. Those who know background coding of that one, they can go and edit the coding. Now in ETABS, if you look at here, this is the beauty of this software. You just unlock this one. Now, once I unlock, it becomes like again in the modeling stage. I can do anything to this one and I can rerun again. Now, the model is unlocked. Now I can go back. I will go to define and start creating our load pattern. Now I will go to the load cases because I need to create a cases. So what I need the live load case, factored live load. So I already have one factored load there. What I need to do is first I need to create cases. Now I will say here case number one, case one. Now, what is our case one? The load has to be applied here and at this panel. But what load we have to apply? Only live load. So I will come and add only live load here, live. And what I will call it, what is the factor? 1.6 because I need to apply a factored live load. So I will say here 1.6 and I will create OK. Now I will go back here. If I need to select these two panels because middle I don't have to apply any live load. So I will go to assign and I will come here. What is the load? Distributed. I will click on this one and I will say live. Now, if you see here, load pattern, what is load pattern is doing? I don't have cases there. Okay. Now, if I apply this live load, because I'm just getting your attention, if I apply live load this one, so how I will deal with the cases? Because case will, what is our case? It is just saying that it is dead plus or live 1.6. It is not telling me which location I have to do. So what should I do? Should I go with the load pattern or with the load cases? If I go, okay, but how you will apply the load? Now look at here, define. Load case is just combination. It is not telling me the location. But when you have to apply a load, you have to deal with the pattern because I need to tell what is the pattern. This is my first pattern. This is my second pattern. So case is only helping me factorizing that one. Okay. It is just helping me factorizing that one. So if I go here, I need to go to the load pattern. I will come here and I will say it as case number one and you name it live load one or live load two. But why I'm following, I'm just saying cases. In reality, I was using live load one or these things. So case one, I will define case one and case one is what? Live. I have to come and click on live. And what should be the self multiplier? One or zero? Zero. Because I said that one means on, zero means off. Now one means computer has to or software has to calculate something. Live load, you are entering yourself always. So pattern should, this self multiplier should be zero. So I will say add. Okay, this is case one. Now I will define all the cases quickly. Case number two will be same. Okay, I can add that one. Case number three, same. But when I'm going to assign the load, then I will define what are the case locations. Then case number four. Now, how many cases we have? If you go here, live load 1, 2, 3, 4, 5, 6. Okay. So I will go and apply case number 6. Add a new load. Now we have 6 load cases. Okay, I missed 5. Okay. So there will be case number 5. Add. Now you have your cases, all 6 cases plus that is already there. Okay. Which is your 7th case. Now I will say, okay, now I will go here and I can come and assign our frame. So load, distributed load. I have to select case number 1. What is the case number 1? It is live load. Now, what is our live load? And I'm using unfactored because I will do the factorization myself. Okay. Now, what is the live load case? What was unfactored value? We'll go back here. Unfactored live load value is 11.6. So I will go here and I will put 11.6. And when you say apply, you can see here now the load is applied on this location. Okay. Is it clear? Now I will say okay. Now I will go back to the define and load case. Now why I need to go back to the load case? Now let us see now our case number one, which I define case number one, or what was your case number one? 1.6. But for which load I said? Live. But do I need for entire or I need for each case? For each case. Okay. So I need to go and make it case number one because it will know this location has to be multiplied by 1.6. This is the option. I will go and I'll click here. Now, what I will do, I will change the name here. You can see editing is very easy anytime. I will call it as live load one because I want to make it different name. Otherwise, what happened now? When I define their case number one, by default, it becomes 11, which was what, if you look at here, one factored. So I will rename this one. These are our unfactored cases. I need to create now factored cases. And what are our factored cases? Live load one. Now I will add a new and I will call it as live load two. What is the case I need to deal? Case two, and I need to factor that one. I'm creating combination first, and then I will apply the load because I did not apply the load. It's just a something I'm creating. So 1.6 quickly, I'll create all the. I don't need dead load. I will just delete that one. Okay. So live load one, and I can move them up to keep it in one sequence also. Okay. Now I will go to add a new, or I can copy this one also. You can see here, add copy of this one. When you click on copy, but you need to change the name and you need to change the case number three. Okay, I will do quickly copies of this one. This will be case number four and factor will remain 1.6. I will copy again and case number will be 5. It will be live load 5 and I'll copy this one and this will be live load 6 and case number 6. Now we have created, you can select them all, you can move them up so that they can be, okay, it's moving one by one. I'm just bringing them to same location. Even if you don't do, there is no issue, but just when I want to read, they are in the same place. So I'm just moving them up. Now we have our combinations also with us. I will click OK. Now this is our live load one. I will go again. Now I will select middle part because what is our next case? If you go here, our next case is the middle part. I will go to this one and I will go assign frame distributed load. What is the case I need to case 2? Value is same because you already defined previously. If it is not showing, you need to put it back. Okay, I will say apply. Now those two loads become hidden. A new load is showing. Now next case number 3. What is that case number? 1 and 2. So I will select this one and I will select here and I will change it to case number 3 and load value is same. Now next our case is the last one only. I will click last case number 4 and I will say apply. And after that we have first and the last two. So I will select this one, case number 5, apply. And then I will click all these one and I will call it as case number 6, apply. Okay. Is it clear? Sir, how we can check the error sales center? There is, if you want to check the error in case what? Modeling error, or because modeling error can be checked before run analysis, you click here, check model. If you click on check model, it will ask what you want to check. You select all these options. Run. It is no warning message were generated, means there is no error. Okay. Now I have the load cases I define, but now I want to show you something. Uh, Before you run the analysis, check everything apart from, because this is a box. We call it computer or the software as black box. Whatever input you give, it will show you results. But how to predict whether they are correct or not, that is your structural sense. Apart from this one, before you run your analysis, check everything. Now I want to see, let's say, what are the loads I applied to this beam. You come and right click on this element. When you right click on this element, a new window is appearing, showing you all the properties what you assign. Now look at here, yesterday we assign it as a beam, which is your cross section. Now you want to check this cross section or change this cross section, you can come here and change the cross section. This cannot be done in very easily in Stat Pro. Next thing, you want to see there are end release which are used for the trust members and other thing, because this is not trust member, so it is none, continuous. These options you need to learn with the passage of time. You will understand what options you have to use, but mainly you need to check the cross section load. What are the loads I have applied? You can see here case 1, case 3, case 5, and superimposed load. Now look at this part of the beam. What are our cases? I have a case 1 where this load is applied, then case number 3, case number 6, and superimpose dead load, which is applied on entire length. So you will see all 4 combinations are there. Okay. Now, if you go to the next one, I click here, case 2, case 3, case 6, superimpose. Now you can verify your loads which you applied, and then you can run your analysis. Again, you will go to, you have two options. Either you press this play button or you can go to the analyze, and from analyze, you can directly run the analysis. Now, when I will click run analysis, I will show you one more option. Now, we have lot of combinations now. We have superimpose, we have dead load, we have live load. What software did, it run for all the load combination. Now you don't want to see some combinations. Okay, you can also stop them. But for the time being, I need results of all of them, and then I need to add them together to get the envelope. So I will run all, and then I will edit and show you the options. Now let us see our first case. If you look at in your class slide, I need to see case number 1 results. Now, if you go here, go to shear force and bending moment diagram, you have an option from this frame, or you can go from the display. Now, from the display, I will go frame, click on this one. Now, which case you want to see? Live load 1, which is factored. You can also see unfactored case 1, but I need to see now factored. So I will click on live load 1. When I'll say apply, you can see here now this is our bending moment diagram. And if you come here, 75.61, all those numbers you will see matching that one. Now you can see here in the class slide, I'm showing lines, not this field diagram. So you can remove this field also to see your numbers directly also. Okay, so that is just a graphical view which you. Now next thing what we need to see is the shear force diagram. And shear always in XZ plane is checked by shear 2 2. You click on this one, you apply, you will see this is your shear force diagram, minus 53 on the last end, and you can see here minus 53.04. The same thing, I can go and now I can select all the load combination one by one. I will go to the load combination 2. I will say apply. This is my shear force diagram for the load case 2. And you will find all your numbers like this way. Now, next thing is our envelope, which I will teach you something manually. And even in the software, you can go with the envelope option. Now, that option, I want you to explore yourself. Otherwise, I can create for you, but I will show you quick. What you have to do is you try to explore. We will deal manually because when you are going to solve your problems, let's say in the exam, you must know how to deal with the manual thing. But if you go to define, you come here, load cases or load combination. Now, if I go here, I need to create what now? Envelope. Do you find any option here for the envelope? No. Now, envelope is actually what combinations of all load, not the case. So I cannot create case. Case means something newly you want to add. You have to go back to the load combinations. This is option which I showed you yesterday, 1.2 dead plus 1.6. You click on this one, you come and create add new combo. Under the combo, you need to create what? Adding or envelope. You will see here envelope. Click on envelope. For which load you want to create? We need to add dead load, but is it service or factored? So I need to decide that one because it is factored. So what I will do, I will go to 1.2 dead load. This is my first commit. Now don't put 1.2 here again because you already factored that one with load name 1.2 dead. Because if you put here, what is going to happen? Double. Now, next thing, I need to add all the live loads factored, which is our live load one case, add live load case 2, add live load case 3, then add live load case 4, add live load case 5, and what else we have? Live load case 6. Did we define? Yeah. Okay, here. Now, but I put scale factor there only 1 because I already factored them here. Yeah, you can put, then you have to define factored here. So you can put unfactored and then you can create factored there. So that is the way of modeling how you want to deal with them. But why I factored them before? Because I want to see individually them also. So when you have already option, you just add them. Now I will say, okay. Now, did you notice one thing here? I'm creating envelope. I will write here envelope. Did I unlock my model? Because the analysis is already run. I'm I I need to look at the results only of these loads. So you can see in Stat Pro, you have to unlock and go back, create that combination. Here already the analysis is done. What I'm doing, I'm just merging those diagrams to get the final result. So I'm not doing, and software is allowing me to do editing. So now I will say, okay, halas, envelope is created. There is no issue. I don't have to unlock, rerun lot of things. Now I will go back to the diagram, click for which combination. Combo means combination. I'll click. I have two combination. One we created yesterday, 1.2 plus live load. Another is what? Envelope. When I click on envelope and I say I need maximum only or minimum. Now we will choose maximum and minimum because here maximum means max positive, minimum means negative, but we have negative maximum also. But it will create case positive maximum and minimum in negative maximum. So I need to get both results. Okay. So I'll keep the same option. and I will start looking for the moment. When you click on this one, happen it's not showing the results. Okay, for shear it is showing. Okay, for moment it should also show. Okay, now it's appear. Now you can see here, it is showing me this envelope. Now this envelope is telling me what is the maximum positive value here, 75.612. Now, if you go here in the class, I did the manual with calculation, and in the middle span, maximum is 75.61 for the live load, and then I will add the dead load. I will get total 129 point. Now, what is happening here? If you right click on this one, you can see now your load combination where you want to find your value. Now, this is how we create envelope. Now, I will go into the class. In the class, I want to teach you the locations. Most of the time, your critical section for positive is the mid span, and for negative, supports distance d away from the support or exactly at the support. So you have to look at, you can get it from the software or you do it manually. So we will deal with that one manually currently, but I just show you this option. In your project, use this option. Don't try to go with the manual because you will take time to collect data from the ETAB, then add them. When ETAB is doing for you, directly take the values directly from the ETAB in your design. So I will just close this one, and that's the things first which we need only for the class slide. Now, what is the next thing important in the software? Let's say you are working now later on. What you have to do is you just for the next task is the design. If you feel your results are okay, you go to the design, click here. You will see steel design, concrete design, composite design, what design you want for this one. Now it is a concrete design. You click on concrete design, you will see multiple options here. You want to design only a group, you want to design entire. If you are not selecting these then even you can select for which combination you want. Click on combination. What are the combination I have? 1.2 and envelope. Now, these are my created combination. Even I can go and I can go to the combination. I will say default design combo. What are default design combo? If I explore this option, you click here, it will ask you what type of structure you are dealing. If you are dealing with the concrete design frame, click on this one and say, okay. What it is going to do, it will create two combination, Decon S1, Decon S2. Why two combination? Because I have only dead and live load. Now let's say you have wind load, you have earthquake load. More is the loads, more will be the combination. Automatically it will collect the combo from the code and run design for you. Now, if you want to see what are these combo, you click on this one, click modify. You will see dead 1.4 superimpose 1.4. Say, now, do I need this one? This is 1.2 times dead load. Already it is factored, means it will become 1.2 times 1.4, very high. So now I cannot do anything. I cannot edit this one. So what is the option? If you remember, when I click on this, they give me one option. Either I can convert this to editable or not. You can see here what is written. If I don't check this one, I cannot edit that load combination. Is it clear? Other option is now select this load combination and convert to combo into editable. But best is go here, concrete frame, convert from the beginning, click OK. Now it created new combo. Now when I click, I can edit this one. I can put factor back. I can delete. I can change this to other. So this is how the code combinations can be changed. Okay. Now I will just cancel this one and we go and just see the design explore. I will go to the again design concrete. Now, what is the next thing? First, you always see code, which code you are selecting. And how we can see, again, I will come back here to the design concrete. First option is telling you view your criterias. What are those criterias? Which code I need to deal? You can come and change even later on. Whatever the default setting I put, I can change anytime. Next, if you don't want to change the code, there are some advanced level options which you when you will do the non-linear analysis. These are for earthquake and other. You have to give all these parameters by from the code. Now look at here. What is our factor for tension? Tension design. What is your phi factor? Moment capacity. Phi is zero point 0.9. Phi. What is phi? 0.9. You can see here already written 0.9. What is your phi for compression? 0.65. For your compression control spiral column in the beginning 0.75, shear 0.75. So already factors are even given there. You, if you want to change, sometimes some regions are allowing you can go until 95% of the capacity. You can even edit this one. But why we want to change the code requirement? Because you have stick to one code, follow its requirement. Don't change that one. After this one, you go and again to the design, click start design. When I click on start design, it will run the analysis. Now look at here, what is I'm observing? It's saying OS. OS mean over stress. The load which I applied, it is failing in that one. Now, in reality, it is not failing because what happened when it created the code combination 1.2 dead times 1.4, what happened? The load becomes very high. So this will fail. Okay. But now I just showed you this thing to predict the result. How you can predict the result? Come and right click on this one. It will show you your combinations and it is failing in which thing? It is failing in steel, flexure, 0. When it is failed, it will show you 0 reinforcement. It is failing also in shear, overstress. You want to see what is the calculation? Go and click on detail. When you click on detail, you will see all the calculation here, which we are doing manually. What is the maximum moment it took? This is the shear now, 100. Under shear, it is failing. What is the moment it took? This is torsional moment. You have other moments, so you need to check what is the reinforcement for that one. You can do these details when you are going to design through the software. So in this case, I've been designing it manually. Later on, you can verify your thing. And in your senior design projects, you can explore these options in if you are dealing. Other, you can see the diagrams here. Diagrams for what? For your members, all those things. You can see reinforcement, detailing, how much, how you have to put. Even now they give us a new option, not in this version, the 21, because I'm showing you from 19th. 21 and 25. Now we have a detailing option available in the ETAB. You don't have to do detailing manually. It will prepare drawings even for you. Directly click on the detailing. It will start giving you the design drawings, which you have to submit to the client or to the contractor. So I will stop here because almost our ETAP tutorial is finished. If you have any questions, you can ask, but let me stop the recording. Okay, otherwise a lot of discussion will come in that one. Okay. So